discuss the topic about Archimedes principle. Okay. Archimedes principle. Now this concept is useful in determining the forces that are acting on a fluid that is submerged or floating along a water surface. Okay, so this is useful in especially in the design of ships and other devices. Okay, so we will derive the what we call the buoyant force, okay, or the force that is acting on a fluid that is submerged or floating in a water surface. So say for example this is your water surface and you have an object. Okay, so this could be in any shape, say for example like that. Okay, so what are the forces that is acting on this object? Okay, so first is you have the weight of the object, and then as well as the forces due to pressure, fluid pressure. Okay, so what we will do is we will enclose this object, okay, in a box. Ito na siyang i-enclose. Okay, so if we will going to draw the free body diagram of this object, so nakakay force that is acting diani area diani so last diani. Okay, so let's call this one F1, F2, F3, F4. Okay, and also you have the this one, the buoyant force. Okay, let's call that one as F sub B. Okay, so what's the name F sub B? F sub B is the force the body is exerting on the fluid. Okay, so the force that the body is exerting on the fluid. Okay, so take note nila on the fluid. On the fluid. So later on, napo ni siya corresponding opposite nga force. Okay? So F sub B is the force that the body is exerting on the fluid. Okay, so if we will get the summation of the forces, no? Say for example, the body is at rest, no? Steady sa flow sa water. Okay, so summation of forces along the vertical direction is equal to 0. Okay, so you have the buoyant force dili na ito nitawagan ng buoyant force, no? F sub B lang isa. Base ma-confuse ta later on. Okay, negative minus weight minus F1 plus F2 is equal to 0. And then, kaning mga forces, mag-cancel na sila. Okay? Okay. So, makita na to, if we will going to rewrite this one, F2 minus F1 is just F sub B plus weight. Okay, weight, ang kaning weight is weight of the object. Okay? That is the weight of the object. And then, no. Kanina lang. F sub B is just F2 minus F1. Okay. Okay. So, para makuha nato ni siyang F sub B, kailangan nato ni may value ani. F2 minus F1. Okay. So, ang value na is, by the way, kulang pa nga itong diagram. Kaninga level height is H1. Kaninga height diyan is H2. Okay, H2. Okay. Therefore, F2 minus F1 okay, F2 minus F1 is just ano na siya? Okay, F2. Diba? Ang F2 is just force dealing surface area. So that is just gamma H2 times area. Okay? And then F1, ang force dere is just gamma H1A. Therefore, this is just equal to gamma H2 minus H1A minus weight. And we know na ang weight ani niya ang weight sa object is naman ang weight sa object. The weight sa object is just equal to ang volume ani, ang weight sa object is just gamma water B rho G and okay times B, right? Gamma sa water times V, that is the weight, right? Weight of the object. Mg. Okay? So, but the volume sa object, kung mo na yung object nimo, ang volume sa object is just mass equal to kulang pa rin eh. Rho G. Okay. Ang volume sa object kaning volume ani is just equal to volume ani nga box, no? Volume ani nga box. Ang unsang volume ani nga box? Volume sa box minus kani minus ani ni result minus ani, no? Okay, so unsa ni siya? That is the volume anak nga water. Okay? Right? So therefore ang volume sa object nimo, ang volume sa box nimo is just kani H2 minus H1. H2 minus H1 times area. Right? Kaninga height, ang height ani is H2 minus H1 and then carry area. No? Minus volume sa water. Okay? Volume sa water. Kani. Okay? So therefore, mahimura ni siyang gamma H2 minus H1A and then rho G is just gamma H2 minus H1A minus B water. So pag multiply ni mo ni makancel out ni siya. Mabili na lang ani gamma V okay, gamma V gamma V, right? Okay, so para dili ka ma-confuse, ibutang sa libro o ana para dili ma-confuse sa velocity. Okay, so unsa ni sa nga volume? Kani nga volume. Okay. By the way, para ning result. Kani sa nga volume is volume of the fluid nga na-displace. Volume of the fluid nga na-displace. Ano yung pasabot na? Okay, kung naakay object, no, nga nag-float there eh. So, unsa ang buoyant force ani? It is just ang buoyant force ana is just gamma of the fluid, kung unsa ang fluid dere, water ba or oil, times volume, sometimes dunot na nila VD, volume displays, kanina volume oh. Kanina volume, dili tibok volume sa object, kana lang volume na muraog na displays ba. Kung kuhaon mo ning object, sa may makita nimo na sa top view na kay muraog ana no, kung kuhaon nimo ang object ba, so muna siya ang volume nga na displays no, volume nga na displays. Okay, unsa ang direction dire sa atong diagram dire, paubos ano man kay on the fluid man the force that the body is exerting on the fluid. Now we know that ang buoyancy is the reaction force, so opposite na ni ano man kay ang buoyant force is the force that the fluid is exerting. So dili na ang body, the fluid is exerting on the body. So paana ang direction niya, pasaka no, the force that the fluid is exerting on the body. So dali naman kaya na siya, imorang kwaon ng gamma sa fluid, so gamma is rho g multiply by the volume nga na displays no, displays volume. That's it, yung makuha na mo ang buoyant force. Okay, so ito nang illustrate using example. Okay, so this is the example. You have a metal part that is hanging by a thin cord from a floating wood block. Okay, so this is the metal part and this is the wood. The wood block has a specific gravity of 0.3 and dimensions of 50 by 50 by 10 mm. The metal part has a volume of 6,600 cubic millimeters. And find the mass of the metal part and the tension in the cord. Okay? So what is asked in the problem is the mass and the tension. Okay? So by the way, for this problem, okay, ang gamma sa water, okay, the fluid is water, is 9,800 Newton per cubic meter. Okay, so what is asked in the problem is the mass of the metal and the tension. Okay, so how do we solve this problem? Okay, so first is we draw the free body diagram. Since duha man ka object, so duha ko din ka free body diagram. Okay, so for the wood, you have the tension, you have also the weight. Okay, no, so dili na lang ni siya line dire, pero ang weight niya is nasa centroid dapat. And the buoyant force of the wood. Second is you have the metal part, and then also you have the tension, you have the buoyant force, and you have the weight of the metal. Okay, weight of the metal. Okay, so ako na may reason. Okay. Now that you have the free body diagram, let's apply the Newton's first law of motion. Okay? Since wala man siya, the objects are not moving, apply na to ang first law. Okay? So, summation of forces along the vertical. Okay, this is for the wood. No? Sa wood block, you have Buoyant force is equal to the tension and the weight of the wood. Okay, for the metal, you have tension plus buoyant force is equal to the weight of the metal. Okay. Okay, so what is the buoyant force of the wood? The buoyant force of the wood is just gamma water, gamma of the fluid, and this kaning volume. So, saan na siya nga volume? Ngayon sa problem, ang wood gun is 50 by 50 by 10. And then, na ay 2.5 nga wala sa fluid. So, meaning kani 7.5 rani. So, therefore, ang volume ani is 50 by 50 by 7.5 cubic meters is equal to the tension and the weight sa wood. So, unsa ang weight sa wood? Ang weight sa wood is just mg. You have, but given man ka nga ang specific gravity sa wood is 0.3. So, this is just becomes 0.3 times gamma water times volume sa wood, which is 50 by 50 by 10 cubic meters. Okay, so given yung gamma, masolve na to ang tension to be equal to gamma water is 9,800. Take note, ang unit niya is Newton per m cube. So, i-convert na to ni. No? Times, ato nang i-transpose dito sa PCAS. Times 50 by minus 0.3 times 50 by 10 mm cube. So, convert na to ni 1,000 mm 1 meter cube. Therefore, ang tension ani is just 0.11 Newton. Okay, so nakuha na to ang tension. Okay, so i-reason na ako ni. So, after ni mo makuha ang tension, kuha na ni mo ang mass. So, makuha ni mo ang mass sa metal. Dere. So, you have the mass of metal times G or times 9.81 is equal to 0.11 Newton plus buoyant force sa metal. Ang buoyant force sa metal o sa wood, dili na sila the same naman. Lahim sila volume. Plus gamma water, which is 9,800 Newton per m cube. Volume sa metal, which is given sa problem 6,000 kay fully submerged man fully submerged. So ang total volume sa metal 6,600 mm cube. Convert na po din siya 1 m. Therefore makuha nimo ang mass sa metal ani to be 17.8 grams. Okay? So that's it. Medyo sayon na rin siya, no? Imanan lang nimo nga ang buoyant force is the gamma of the fluid times the displaced volume. Okay?